welcome to my channel. Today we will walk you through the process of conducting a t-test in Python, a statistical technique used to analyze the difference between the two group mean. We have a hypothesis first. Null hypothesis, there is no significant difference between the mean of the population. And alternative hypothesis, there is significant difference between the mean of a population. And here we are going to use alpha value 0.0. First, we import some libraries. First, import pandas as PD, and from SciPy we import the stat, and from stat we import Levene test and t-test of individual. So we have here, and I will run this code completely. So as you see, we have a check. Then we load the data from an Excel file using the pandas function. Here I have a pandas function pd.read_excel bracket. In the bracket here I will provide the path of my file including the file name, and we save this whole data in the data frame called df_t-test, and we run this function here to read our Excel file. And now we can see we got the check mark here, and our data file is read properly without any error. So now we can see our data by running the function df_t-test, and when we run, we can see we have man and woman body temperature data, and here we got nicely two columns indicating the temperature of the man and woman. Total number of the rows are 64, and we can see here in the women data we have two NA values. Now we subset the data for the male and female body temperature using the function like this. Man_temperature, we make a data frame for the man temperature. df_t-test is our data set, and here we put in a square brackets and double square brackets to subset the data. In inverted commas or double quotes we give the man, because here we have a column for the man body temperature, and the same we do for the woman body temperature, df_t-test, and in the double brackets we give the woman vector data name. And as we knows our woman data have NA values, so we use a function called drop NA from the woman data set. So here we write all these three codes and run the data or this code of chunk here, and we get our man and woman data temperature. Here we can see our man and woman data by running code separately, or we can print this by running the code like this. And so we got the woman temperature here, woman body temperature here, and the same we can do with the man. Just we write here man_temp, and we run the code here, we get the man's body temperature data here. So our data sets are nicely subsetted in the two different data sets. Now here first let's check the normality of the data using the Shapiro test for both the data sets, man body temperature and the woman body temperature. And for this we write here statistic comma p-value equals stat.shapiro, and in the bracket we give our vector or a variable, and here we want to print the result of the test, so we write a print in the bracket statistic and print p-value, and we just simply run this code here, and it gives us the statistic value 0.98 and the p-value 0.39 for the man's body temperature. The same we will calculate for the woman's body temperature also. We repeat the same code of chunk with our woman variables data. So here the same we write a statistic p-value and stat.shapiro, and we give variable woman's_temperature, and we run this code also. The output of this code is also a statistics is 0.965, and the p-value a little bit greater than our alpha value of 0.05. Here in both the data sets the p-value is higher than the 0.05, so this indicates that our data is normally distributed. Next we check the homogeneity of the variance using the Levene test. So how we gonna perform the Levene test? Very simple. We do here the statistic p-value equals, we just call the function from the stat and give both the variables here in the bracket man's body temperature comma woman's body temperature, and we want to print the statistics and p-value of the Levene test. So we just write here print, and the inverted double quotes we says the Levene test statistic colon comma statistics and the print p-value, and we just simply run this code of chunk here, and it gives us a very nice output where we see the Levene test statistic is in a 0.95 is a less than 1, and p-value is 0.33, which is greater than alpha value 0.05. Here both the tests, Shapiro test and the Levene test, provide enough evidence to proceed with the t-test, or we can say that both the tests providing enough evidence to proceed by the t-test. In the Python, t-test is very simple to apply. So here we just call the t-test from the SciPy library, and we say that t_statistic p-value equals to t_test_ind individual, and we give both the variables of man body temperature comma woman's body temperature. Want to print the output of the t-test, so we write here print in the double quotes t statistic. Don't forget to give the colon comma, and t statistics. In the print, invert in a double quotes p-value colon, comma, and p-value, and simply we run this code of chunk here and gives us output in the t statistic is in minus 2.02 and the p-value is 0.04, which is slightly less than our alpha value of 0.05. So on the base of the p-value, we simply reject the null hypothesis and suggest there is a significant difference between the two groups. So that is for our tutorial conducted t-test in Python. I hope you found this video helpful in understanding how to conduct and interpret t-tests in Python, and stay tuned for the more insightful tutorials on statistical analysis and data visualization. Don't forget to like, share and subscribe for more content on the data analysis and the programming tutorial in Python. Thank you for your attention.